Welcome to the Crazy Hat Chemist. So here's another video in atomic structure and electron configuration. So let's get started. Bam! So today is talking about the principal quantum number. The principal quantum number is N. N is the principal quantum number. Okay, what does the principal quantum number mean? The principal quantum number N describes the energy of the electron as its average distance from the nucleus. It's a relationship between the size and energy of an atomic orbital. It is called the shell. Okay? N is positive whole integers. That is 1, 2, 3, 4, 5, 6, 7, 8, all the way up to infinity. N increases as the electron moves farther from the nucleus. Each shell, that is N, contains N number of subshells or values of L. You're going to have to wait for the second quantum number to find out more details on that. Here's an example though. If N is equal to 4, then there are 4 subshells, that is values of L. Okay, so that is a 4s, a 4p, a 4d, and a 4f. Those are the subshells. Okay, so for the future. Okay, the maximum number of electrons in N is 2n squared. So if you were to plug in a 1 into there, do you have 1 squared times 2? That's 2. 1s orbital, 2 electrons. That's the maximum number of electrons that you can fit in there. If n is equal to 2, then it is 2 squared, which is 4 times 2, which is 8. Okay, I'm going to let you do the rest of them there. Okay, and we're going to come up with some of those numbers also. A little bit more detail here. As n increases, the electron moves farther from the nucleus. So the electron is farther from the nucleus, and this is really looking at, if you imagine, the Niels Bohr model. Even though that is incorrect, it is a good reference to this. Okay? N is like the rungs to the ladder. I've already talked about that, but just to reiterate that. Okay? The rungs are not equal distance. Okay, they are a large distance from the nucleus to begin with, and as you get progressively farther away from the nucleus, they do not get progressively equal distant away. They are not nearly as far away. Okay, electrons can be placed at the rungs, but never in between the rungs at all. Okay, and so here's an example of a ladder like what we have. We have the nucleus right there in the middle, okay? And then here's an electron. This electron is at the rung of a ladder. That's the yellow section where you place your feet, okay? The rails to the ladder are the black sections of this example. N equals 1, so you can place an electron in N equals 1. That's the first energy level. It is closest to the nucleus. As N increases, then the electron will move farther from the nucleus. That's N equals 2, N equals 3, N equals 4, N equals 5, N equals 6, N equals 7, all the way up to infinity. But for our periodic table that we currently have, N equals 7 would be a good high N number. Notice that the distance between N equals 7 and N equals 6 is very small in comparison to the distance between N equals 1 and N equals 2, where it is rather large. Okay? Now, where can you not place electrons? You cannot place an electron right here because that's in between the rungs of a ladder. So it's an impossible location. It's like a node. Okay, as you look at the standing wave. This is still not at the rung of a ladder. It might have almost the right amount of energy, but it most certainly doesn't. I want you to think about Einstein's experiment with the photoelectric effect. And there was a certain amount of energy that was necessary. So if you imparted enough energy, okay, then you made it to the next rung on the ladder, and then that electron dropped back down and emitted light. However, unfortunately, like that last one that I put on there, it almost made it up to the next rung, but it didn't quite, so it just stays at the lower level. Okay? And of course, you cannot have an electron in between the nucleus and the first step of the ladder, that is the first N value for the principal quantum number. That's impossible too. Okay? Good. All right, that was another crazy video from the Crazy Hat Chemist, and I am the king of videos for chemistry. If you like that video, give me a thumbs up. If you like my videos, give me a subscription to my YouTube channel. Okay? I'm the king of chemistry.